Okay, so ladies and gentlemen, in this video, we are going to look at electrical lines of forces. Introduction to electrical lines of forces. So electrical lines of forces are imaginary lines that represent the direction of electric field around a charge. So if you want to measure, or if you want to indicate the direction of electric field around a charge, so you use an electrical lines of forces. So they're imaginary lines that represent the direction of electrical field around a charge. They help visualize the strength and the direction of electric field at different points in space. So very important, ladies and gentlemen, should understand that electrical lines of forces, because electric field intensity is a vector quantity. So you can use an electrical lines of forces to measure both the magnitude and the direction of the electric field. So that is why at the same time, electrical lines of forces can help to visualize the strengths and direction of electric field at different points in space. These lines usually originate from positive charges and terminate at negative charges or extend infinity or infinitely. So for example, look at this diagram where we have positive charge and negative charge. As you can see clearly that from here, you can see that from here, this is a positive, and from this positive, we can see that the electrical lines of forces are originated from positive charges, and then they move away. So look at them here. We have them. All these are electrical lines of forces. So they are originated from positive charge, and also if you look at them, they are terminated at negative charges. So they are coming from infinity and terminate themselves at negative charge. And of course, in the case of positive charge, they are originated and diverge themselves. So they move away from positive charges. So they are generated from there, and then they move away from the positive charges. So from here, I think, ladies and gentlemen, by looking at this, we can say that the electrical lines of forces, it looks like positive, because remember, positive and positive repel each other according to electrostatic law of attraction. That is electrostatic law of electrical, according to this scientist, Benjamin Franklin, is the scientist that state electrostatic induction. That is the law of electrostatic induction, where like charges repel while unlike charge attract themselves. So that is why, because as you can see from here, because these electrical lines of forces, they are positive charge. So that is why they are moving, they are originated, and also they are moving away from the positive charges. And because they are negative, and that is why they are terminated and consumed by negative charge, meaning that there is attraction there. So what are the properties of electrical lines of forces? Electrical lines of force, they never intersect each other. You will never see electrical lines of forces. Like for example, let's say this is one and this is another one. So they would never intersect, ensuring a unique direction of electric field at any point. So there is no any intersection of electrical lines of forces in order to ensure a unique direction of electric field. And the density of the lines indicate the strength of electric field. So the higher their density, indicating the higher the electric field. and closer lines mean a stronger field. So whenever you have a closer electrical lines or pulses, it's an indication that you have a strong electric field. They always start from positive charges and end at negative charges, or extend outward if the charge is isolated. So usually the extent outwards if the charge is isolated. So we have isolated charges. So in the case of isolated charges, these electrical lines or pulses, the extent outward of the system. So now let's look at it from diagram here. You see, this is a positive charge and this is a negative charge. And as you can see, they always start from positive charge and then they end at the negative charge. So what are the rules for drawing electrical lines or pulses? The lines should begin on positive charges and end on negative charges or go to infinity. So this is the first rule. Whenever you want to draw electrical lines or pulses, so you always start from positive charge and you end it on a negative charges, or it goes to infinity. The tangent to a line at any point gives the direction of electric field at that point. So whenever you have a tangent to a line at any point, so that means it's trying to give a direction of the electric field at that particular point. So the lines are drawn such that they are smooth and never cross each other, maintaining a continuous path. So if they're moving in one direction, so they are moving in that direction. They don't intersect one another. They don't cross one another. They always maintain a continuous path. So then electric field around different charge configurations. For a single positive line charge, the lines radiate outward uniformly in all directions. So when you have a single positive point charges, all the electrical lines or forces radiate outward uniformly in all directions. And then for a dipole, lines originate from positive charge and curve toward the negative charge, forming a closed loops. So if you are dealing with a dipole, a positive charge the lines of pulses originate from positive charge, and then they form a curve toward the negative charge, which lead to a formation of closed loops. And the pattern of lines varies depending on the arrangement and the magnitude of charges involved. So there are different patterns. There are different patterns of electrical lines. Sometimes they are straight. Sometimes you see that they form a curve. Sometimes you see that they form, they actually forms different pattern, but depending on the arrangement and the magnitude of the charges. So what are the significance of electrical lines or pulses? They provide a virtual representation of electric field, aiding in understanding electric interactions. That is number one. And the lines help determine the direction and the relative strength of electric field at various points. So that is why number one, you use electrical lines or forces to determine the direction and also the strength of electric field. The more closer they are, it means that the stronger the electric field. So understanding these lines is essential for analyzing electric forces in practical applications like capacitor and electric field shielding. So ladies and gentlemen, this is where we are going to stop. Please don't forget to subscribe and join my YouTube community. See you next in my next video.